Viewers like you make this program possible. Support your local PBS station.
The Dead Sea. One of the most extraordinary places on Earth.
The Dead Sea is unique in many, many aspects. Its chemistry, its evolution, its composition.
Its healing powers are well known, and it was the setting of dramatic events in the Bible.
It was considered a very unusual and extraordinary place in antiquity.
The Dead Sea is very special. It's a treasure.
But now, this wonder of the world is vanishing. The shoreline pockmarked with sinkholes.
1/3 of the Dead Sea surface has been lost because of the lack of water.
The sea is in desperate need of water. In one of the most water-scarce regions on the planet, the Middle East.
Access to water is a fundamental basic human right.
Now, a team of scientists has developed an innovative and daring plan to help solve the region's water shortage and at the same time save a dying sea. But will it work?
We can destroy it if we intervene too much.
Saving the Dead Sea. Next on Nova. It is the lowest place on the surface of the Earth, more than 1,400 feet below sea level, 10 times saltier than any ocean. In ancient times, this sea was considered a threat.
The way it's presented in the Bible can be quite negative. Sodom and Gomorrah were engulfed by the Dead Sea as a punishment by God.
But this sea has also been treasured for its unique chemistry. Aristotle wrote about its remarkable water, where everything floats. According to legend, Cleopatra ordered her lover Mark Antony to conquer the sea because of its mystical powers. For thousands of years, pilgrims have come here to bathe in its healing waters.
The Dead Sea is really very unique, very beautiful.
But now, this one-of-a-kind sea is receding at an alarming rate.
We need a lot of water here. The water balance here is so in overdrafts.
Back in the 1960s, the shoreline was almost up to the road. Now, in some areas, it's a mile away. And as the water declines, the beach has become inundated with sinkholes. 6,000 and counting.
It's like the craters on the moon, but here it's not the moon. This is a dying sea.
Just 3 years ago, this beach was visited by tourists from around the world.
Now they evacuate the place. All the infrastructures around, they've been shut down, like there is a gas station, and there used to be a restaurant here. It looks like a bomb area. It looks like a war. Look at this, we're just walking on something that used to be road. This is a very dangerous area. It is very, very important that something be done here.
Now, a massive engineering project is in the works to bring water back to the sea. But will it succeed? Can the Dead Sea be saved? What's happening to the Dead Sea is the age-old story of life in the desert. The story of water. The Dead Sea is in the heart of the Middle East, bordered by Israel, the Palestinian Authority, and Jordan, a region that is home to 5% of the world's population, but just 1% of its water, making it one of the most water-scarce regions on the planet.
Palestine, Israel, and Jordan are mostly desert since the biblical time. Since the beginning of history, we know that we have a shortage of water.
The secret of the life in this area is the water. And the rule is, if there is water, there is life. And if there is no water, there is no life.
All people need water. Israeli as well as the Palestinian, Jordanians as a human being. Water is not a choice. Water is a must.
But to solve the region's water shortage, Israelis, Palestinians, and Jordanians have to overcome years of conflict.
This is the most troubled area in the world, and the Israeli-Arab conflict has been running for the last 70 years or more. Always water is there if countries want an excuse to initiate a conflict.
Water can be a cause of conflict, but we will prefer it as a means of cooperation.
In a unique three-way agreement between Israelis, Jordanians, and Palestinians, a plan was developed called the Red Sea-Dead Sea Project.
The Red Sea-Dead Sea Conveyance Project speaks about supplying drinking water for the Middle East and stabilizing the Dead Sea. That's what the Red Sea-Dead Sea is about.
It is an elaborate plan with many steps. Jordan will get more water through a pipeline from a lake in Israel called the Sea of Galilee. The Palestinian Authority will get more water too from the existing Israeli water system. And in southern Jordan, a desalination plant will be built on the shores of the Red Sea. The salty leftovers from the process of desalination, called brine, will be transported through a massive pipeline and emptied into the Dead Sea to raise its level.
It's a regional cooperation project. I think it's the first one and the biggest one between Israel, Jordan, the Palestinian Authority.
This plan could represent an important step in bringing peace to the region. But at the same time, is it good for the Dead Sea? It is one of the world's largest water experiments, and no one is sure if it will work. For scientists, the project is an enormous challenge that involves linking two seas that have never been connected in all of human history: the Red Sea and the Dead Sea. The geology of the region has made the Dead Sea one of the most mineral-rich bodies of water on Earth. No one knows exactly how a massive influx of Red Sea brine, the leftovers from the proposed Jordanian desalination plant, will affect its unique chemistry.
The composition of the water is very complicated. It's not similar to any other seawater on Earth. Every time that we are working with the Dead Sea, we have many surprises.
Here at Ben Gurion University in Be'er Sheva, Israel, researchers are trying to eliminate those surprises. They're mixing Red Sea water, or brine, with the unique water of the Dead Sea.
In the laboratory, we're trying to do experiment. We're playing with different ratio, different concentration, different temperature. We're playing with all the conditions in order to learn what will happen to the Dead Sea.
After months of mixing, they make an alarming observation.
the Dead Sea, instead of the regular color, could turn white.
Tiny white crystals could form. There's no doubt it will be a shocking aesthetic change. What causes this strange transformation? A mineral called gypsum. It's used in plaster of Paris, wallboards, orthopedic casts, even toothpaste. Gypsum is a combination of calcium and sulfate. It turns out that the Dead Sea is rich in calcium and the Red Sea rich in sulfate.
Combined together, you get gypsum crystals.
In the lab, some of the concoctions the scientists cook up form gypsum in a matter of hours. How long this process will take when Red Sea brine meets the Dead Sea on a massive scale is unclear. Will it take years, or perhaps never happen at all?
If we say that there is something that we fully understand, then we are lying to ourselves. I think that being a geologist, one of the things I learned is modesty. The conditions in nature are much more complicated than in the laboratory.
To play it safe, the scientists recommend bringing in a small amount of Red Sea brine to start.
You don't want to camp to help the Dead Sea and find yourself harming it. Therefore, the decision is to go in stages.
And if a smaller amount doesn't affect the sea's chemistry, they'll add in more, bit by bit.
And in the future, when we will have the second stage and the third stage, the Dead Sea will be stabilized, finally.
Stabilizing the sea will end its decline. But the amount of Red Sea brine it will require each year is hard to fathom. Almost 200 billion gallons. But whitening is just one of the challenges. Brine from the Red Sea is only about 7% salt, while the Dead Sea is a whopping 34. Mix them together, and it could lower the Dead Sea's salt content. And that might turn the sea red. Just like it did right outside of Salt Lake City, Utah, in America's Great Salt Lake.
When one flies over the Great Salt Lake, one sees that the northern lake is in fact red.
A large causeway divides the lake in two. One end gets very little fresh water. And when its salt content rose to more than 25%, it became the perfect breeding ground for algae. Researchers estimate mixing Red Sea brine and Dead Sea water will hit the same salty sweet spot, and the sea could turn red. In fact, the growth of algae has occurred in other salt lakes, like Lake Retba in Senegal and Lake Hillier in Australia. Unlike red tide, the algae that might grow here would not be harmful to humans, but the sea might never look the same.
The scientists will say, look, this is a consequence. What can we foresee and what can we predict?
Predicting how nature will respond to the mixing of two very different seas is just one of the problems researchers face. Unraveling the mystery of where and when the next Dead Sea sinkhole will form is another. Geohydrologist Karmit Ish Shalom is trying to do just that. For years, she measured sinkholes the old-fashioned way, with a measuring tape.
It's very, very sophisticated. You just throw it down there.
But for areas where sinkholes are just beginning to develop, she uses a drone.
We can see the whole sinkhole from above, and we can see how big it is. Each month we're monitoring them, trying to see the changes in the size, in the depth, how fast they form. There's many kinds of sinkholes in the world. The kind that we have here in the Dead Sea is very unique.
Most sinkholes form in rock, like limestone. But here at the Dead Sea, they're caused by salt. As the sea declines, an underground layer of dry salt is left behind. Fresh water, like in winter flash floods, saturates that salt, which quickly dissolves, creating an underground cavity. Over time, it grows bigger until, suddenly, without warning, the earth above it caves in. While the cause of Dead Sea sinkholes is well known, after 20 years of careful measurement, there is still no detectable pattern for sinkhole formation. Each sinkhole seems to follow its own rules.
We don't really know when the next one will form, next year, or maybe 2 years from now, or maybe tomorrow. It is just a miracle that nobody got hurt or died in a sinkhole.
But if the sea doesn't get more water, that could change. More sinkholes will form. As many as 500 a year are predicted. What brought the Dead Sea to such a sorry state?
Really, the Dead Sea is the victim. The Dead Sea is the ultimate victim of the water shortage in our region.
To understand why, we travel from the arid desert to the Sea of Galilee in lush, green northern Israel. This sea has played a vital role in the history of the region, as well as the history of the Dead Sea.
Sea of Galilee is actually the one and only freshwater lake in Israel, producing water for years for all the country.
Water from the Sea of Galilee flows south, down an ancient river rich in history.
The Jordan River is the actual site where John the Baptist was baptizing Jesus.
And for thousands of years, the Jordan River provided a constant supply of water to the Dead Sea. That is, until a powerful force altered nature's plan. Us. Back in the 1950s, when the population of Israel was growing, the young country was in desperate need of water.
When you have growing needs, you have to supply more water, not only for agriculture, but also for domestic use.
So Israeli engineers came up with a novel idea, a way to expand the Galilee's reach. They built the National Water Carrier, a massive series of open canals, pumps, and pipes that diverted millions of gallons of water from the Sea of Galilee. Water that once flowed down the Jordan River into the Dead Sea, instead went to cities on the Mediterranean coastline and to the Negev to make the desert bloom.
And by doing this, we could settle people in the desert.
But in the process, the Dead Sea's main source of water was cut off. So was an important source of water for Jordanian and Palestinian farmers and communities.
Over 96% of the water flowing from the Jordan River into the Dead Sea has been diverted and no longer reaches the Dead Sea. This is a man-made disaster. What happened to the Dead Sea is a man-made disaster.
Those who doesn't know about the Jordan River, they think it's like Mississippi or Amazon. It's a stream. It's not even a stream.
When people closed the Jordan River, they never thought, is it safe to do it? Is it okay to do it?
But the national water carrier is not the only cause of the Dead Sea's decline. Today, Israel and Jordan are mining the sea for a valuable mineral called potash, a form of potassium and a key ingredient used in fertilizers worldwide.
Potash is a major income and a major employment to Jordanian and Israelis. For Jordan, this is a business of $500 million per year.
And in Israel, along with potash, the Dead Sea Works produces a number of products like magnesium chloride, table salts, and bromide. It employs thousands of people and brings billions into the economy.
The land of Israel doesn't have natural resources. We don't have copper, we don't have steel, we don't have coal, we don't have almost nothing. We have only one natural resource, the Dead Sea.
In order to access these resources, both Israel and Jordan have transformed the southern part of the Dead Sea into a series of artificial evaporation ponds.
This is not a sea. It's part of a factory.
The ponds are on average only 6 feet deep, which makes it easier to dredge for minerals. But it also creates a problem that can best be seen from space. This satellite image reveals the Dead Sea is divided into 2 strikingly different basins. The northern basin, where sinkholes abound, and the southern basin, where the potash industry thrives. As minerals are dredged from the sea, the shallow ponds need to be replenished. So the potash industry pumps water from the northern basin into the ponds. These satellite images taken between 1972 and 2011 reveal a stark reality. As water is pumped out of the northern basin, it's shrinking. But the potash industry is not the only stakeholder. So is another industry, and one of Israel's biggest: tourism, which brings in $5 billion to the Israeli economy every year. This is Ein Bokek, where tourists come to float in the salty water. In fact, the sea's high salt content makes the water so dense, swimming is almost impossible, but floating with a book, remarkably easy. Since antiquity, travelers have come here to bathe in the sea's mineral-rich water, cherished for its power to heal. Elizabeth Liepman has been coming here once a year since she was 14. For her, just breathing the air helps treat her eczema, a debilitating skin disorder.
It's very painful, keeps you from sleeping, keeps you from concentrating, keeps you from work. After about 1 week, 10 days, the symptoms are mostly gone, and I'm beautiful again.
Researchers have discovered the secret behind Elizabeth's recovery: minerals. The Dead Sea has 20 times the potassium, 80 times the bromine, and 32 times the magnesium of regular seawater. By normalizing cell growth and reducing inflammation, magnesium can help heal a variety of skin diseases.
The Dead Sea has plenty of magnesium. We have it in the air, we have it in the rocks around us, in the mountains, and we have it also in the waters. So we are the golden city of magnesium. I've spent the 40 last years of my life here, and I am still amazed by the results that we can obtain.
What makes the sea so rich in healing minerals? Geologist Shmuel Marco has spent decades exploring the Dead Sea region, uncovering clues to answer this question. The sea's unique chemistry is intricately linked to where and how it formed.
The special thing about this place is that it's a rupture in the crust of the earth. It's where the two pieces of the earth break from each other. They move against each other.
The Dead Sea region was formed when the crust of the earth broke into two pieces, the African plate and the Arabian plate. As these plates moved against each other, they formed deep gaps in the surface of the earth.
About 20,000 years ago, in the last glacial time, when glaciers covered large parts of the earth, the gap filled with water, we call it Lake Lisan. And it filled the whole valley from the Sea of Galilee in the north to the Arava Valley in the south.
As time passed, Lake Lisan grew smaller and smaller, eventually turning into the Sea of Galilee, the Jordan River, and the Dead Sea. The Dead Sea is a terminal lake. Water flows in but can't flow out because it has no outlet. In this hot, arid desert, it evaporated. What was left? Water saturated with salt. This salty water interacted with the surrounding rocks, leaving behind a sea rich in minerals. This abundance of minerals has made the southern basin an economic powerhouse. The same can't be said for the northern basin. The consequences of the sea's decline can be felt everywhere. This once lucrative date grove at Kibbutz Ein Gedi was abandoned after a worker suddenly fell into a sinkhole. So far, 25 acres of date and mango groves have been destroyed. And the number of visitors to Ein Gedi's world-famous spa is dwindling. The beach is so far away, you need to take a tram to get to the water's edge, which once came right up to the spa. All told, by the end of 2017, Ein Gedi had incurred more than $30 million in damages.
Who knows what will be in the future? It doesn't sound good.
Up the road from the spa is an excavation site where Gidon Hadas has spent decades preserving Ein Gedi's rich history.
We have a history of 1,000 years of Jewish settlement from the 7th century BCE until to the 6th century Common Era.
This is a region where there's some amazing archaeology, whether you're going down on the Israel side or the Jordan side or going into the Palestine National Authority and going to Jericho. The archaeology is just fantastic.
The Dead Sea Basin includes the most important sites for all religions, Judaism, Christianity, and Muslim.
The ancient ruins of Masada are here. The Dead Sea Scrolls were found in caves near the sea. And as the sea has receded, Gidon even discovered evidence that ancient ships once sailed here on the salty sea.
I was walking on the beach. I look at the stone, and I look at it, and look at it, say, wow, that's a Roman anchor.
These stone anchors date back to the 1st century BC.
The Dead Sea had trade routes leading east to Arabia and beyond. So it wasn't as disconnected as you might imagine. It's not a sort of wilderness place in the back of beyond. It was really key to ancient economics.
But today, the economy on the Israeli side of the northern basin is imploding. And no one knows how long living here will be sustainable. Just 50 miles away, across the border in Amman, Jordan, the region's water shortage has also reached a dangerous threshold. The country's population, just 900,000 in the 1960s, has skyrocketed to close to 10 million. In just the last few years, more than 1 million refugees have poured in from war-torn Syria.
The impact of the Syrian refugees on Jordan is huge. And this additional demand increases our water demand by 22%.
In an effort to conserve, the government limits the number of days running water is available.
Here in Jordan, we get water once a week, so we use and store as much as we can in one day.
But there's a novel way women are tackling Jordan's water shortage. They're learning a new trade: plumbing.
When I told my family about the training, they laughed because they thought I was joking.
Many Muslim women are not permitted to be home alone with a male who is not a family member. This delays repairs. And billions of gallons of water are lost through leaky pipes.
If we women learn this job, we will be better at it than men because we are always learning better than men.
Conservation is making a difference, but it's not enough. As the need for water in Jordan and in the Palestinian Authority becomes more pressing, it will continue to be an issue.
Water is one of the core issues of the conflict between Palestinians and Israelis, but also water is the issue where the party keep talking to each other despite the difficult time.
This is where the Red Sea-Dead Sea Conveyance Project can make a real difference. And perhaps even end the region's age-old water shortage. The key to its success is a technology Israel has spent decades perfecting: desalination.
We solve our problems by manufacturing water.
During the last decade, Israel has constructed 5 huge desalination plants right on the shore of the Mediterranean.
Desalination, another essential part of the Red Sea-Dead Sea project, is the process of transforming seawater into fresh water good enough to drink. Israeli scientists and engineers spent years improving this process, making it more affordable. Seawater is carried by pumps into massive pools where it passes through a layer of sand. Large objects like seaweed and the occasional fish are left behind. Next, the water travels through fine filters that remove microscopic particles like bacteria. The water is then pushed with tremendous force through sophisticated membranes that allow smaller water molecules to get through, but not larger molecules, like salt. Finally, fresh water makes its way into the national carrier system, and the salty leftovers, the brine, is returned to the sea. Desalination used to require a lot of heat and was energy intensive and costly. But with new technologies and advances in membrane design, the price of water has been cut in half. Israel has also developed innovative technologies in drip irrigation and water recycling.
We have very good technology. We can create water.
This gives Israel a unique technological edge, and a powerful hand on the tap. At times, it used this power to limit the flow of water to Palestinians, which has heightened tensions in this water-scarce region. But can water be used in a different way?
If we should be wise enough to use this technology in the right direction, it will create an incentive in our neighbors to make peace with us. That's my hope, that's my dream.
But even if desalination provides enough water for the region, transporting water to where it's needed most presents a major challenge. As part of the plan, the leftover brine from the new desalination plant in Jordan will be pumped through a pipeline to the Dead Sea. The pipeline will be built near an aquifer, an underground reservoir of fresh water, used by local farmers in Israel. And this presents a problem.
The water is seawater or brine, which is very, very salty. And if there is something like earthquake, then the aquifer will be ruined.
We have records of earthquakes in this area, in particular earthquakes around and in the Dead Sea Basin, throughout history. Even the Bible describes earthquakes.
You have the story of Jericho, where Joshua's armies came through and the trumpet sounded. And the walls of Jericho fell down. There's been a huge debate whether there were, in fact, walls of Jericho that did come tumbling down at some point due to an earthquake.
How often do major earthquakes occur in this region? The history is well documented, etched in the cliffs that surround the Dead Sea. During the last ice age, which ended around 12,000 years ago, this whole area was covered with water.
We are at the bottom of a lake, and what we see on the cliffs are the sediments, the deposits that accumulated at the bottom of the lake. What you can see here is that the rock is composed of two types of materials. There's a dark layer and a white layer.
The darker material is made from tiny rocks that settled on the bottom of the lake.
It was deposited at the bottom of a lake during floods. Usually the floods here are in the winter, so this is a winter deposit. Now the white material, right here, is considered a summer deposit.
The summer deposit is made of calcium carbonate, a white compound found in seashells.
And everything stays like this until something shakes them. And right about here, we see the same material, but here it's chaotic.
The signs of an earthquake.
So we have like a tape recorder that recorded earthquakes during 50,000 years.
But the region's earthquake record is even longer. A record provided by the sea itself. An international group of scientists drilled 1,500 feet beneath the sea floor.
We drilled a hole about this big,
pulling up cores of ancient sediment that document environmental changes in the region over time, from climate to earthquakes.
We reached layers that are dated at 220,000 years. So altogether, we have a 220,000 years record of earthquakes.
And within that record is evidence of several major earthquakes. And we know that a couple have occurred in relatively modern times. In 1837, the Galilee earthquake shook the region. In 1927, an earthquake felt from Jerusalem to Jericho resulted in hundreds of deaths.
We haven't had a serious earthquake actually in the Dead Sea for a while, and it's sort of due.
Geologist Shmuel Marco is concerned whether the Red Sea-Dead Sea pipeline would survive it.
In my opinion, it's very problematic. It's a large interference with nature, a long and active geological fault with many earthquakes.
A few days ago, there was 100 earthquakes registered in one day. So there is a risk. There is a risk of earthquake in this region.
So we are always worried about what I term megalomaniac programs. Let's do and change nature.
The nature marine biologist Amatzia Ganin is striving to protect is another extraordinary sea, the Red Sea. 1,400 miles long, a sea so massive it's twice as large as all the Great Lakes combined. Its northeast end is called the Gulf of Aqaba, and it's home to some of the most pristine coral reefs on the planet, rich in color and life.
We are here near the tip of the Gulf of Aqaba, which is part of the Red Sea. It's a special ocean. This is the only place, the only piece of ocean on Earth where bleaching has not occurred.
Corals worldwide are undergoing a troubling transformation. As the oceans warm due to climate change, corals are losing their vibrant color as they lose something vital for their survival: algae, which provides corals with essential nutrients.
They lose the algae, they become white, and if they don't reacquire the algae, they die. And about half of the corals in Australia, in the Great Barrier Reef, about half is gone now because of massive bleaching. It's a major risk to the coral reef, and it occurs all over the globe, except one place on Earth, the Gulf of Aqaba.
The biological underpinning that makes these reefs so robust is still unknown. But scientists think these corals originated farther south and migrated here already accustomed to warmer waters.
So we predict that the corals in the Gulf of Aqaba will have perhaps 100 years more than any other place on Earth before bleaching starts to hit these corals.
Another 100 years before the temperature of the sea becomes intolerable. But this resilient reef could still be at risk from the new desalination plant that will be built in Aqaba, Jordan. There's a concern that when water is pumped out of the sea and into the desalination plant, it would take the tiniest forms of life with it.
So we brought that simple plankton net that filters the water. We'll tow it from the boat. Hopefully we'll get some larvae inside the net.
In just a few minutes, Amatzia and researcher Irina Kolesnikov pull the net from the water and find that it's teeming with life.
We have here some coral larvae.
Larvae.
Let's have a look at them.
Developing snails, mussels, crustaceans, fish, and budding coral. All could be put at risk through desalination. Where the plant will be located on the Jordanian side of the Gulf is the site of a large concentration of larvae.
The coral reefs here depend on larvae arriving from Jordan.
And when the desalination plant is built there, the damage could be irreparable.
Lots and lots of larvae will be pumped and then delivered to the Dead Sea where they will die. Let's go down. We are worried that that will have an effect on the well-being, on the renewal of the coral reef.
So a team of Israeli and Jordanian scientists sets out to find a way to minimize the damage. and they make a discovery.
The larvae of the coral reef animals are much less abundant, to an order of magnitude less abundant, below where you have sufficient light for photosynthesis. We call that the photic layer.
Pumping below the photic layer, about 400 feet below the surface, puts far less life forms at risk.
Problem is that it's very costly. You need deep sea divers. Everything is so much more complex than doing it at shallower depth. We say, you guys are going now to do a project, take the water from the Red Sea, deliver the water to the Dead Sea. This will cost, I don't know, hundreds of millions of dollars. So invest $2 million more to build a system that will conserve nature here. Invest now and gain big time in the future. We are all fully aware of the severe shortage of water in Jordan. They need water, no doubt. So we really went very willingly to try and see how we can mitigate the potential hazard to the coral reef. And indeed, we found.
From the Red Sea coral reefs to a vulnerable pipeline, to the impact Red Sea water could have on the unique chemistry of the Dead Sea. There are many challenges and many unknowns for the Red Sea Dead Sea project. Could there be a better solution? Why not simply undo the damage, restore the flow of water to the Jordan River and to the Dead Sea? The problem is, as the climate warms, the Sea of Galilee no longer has water to spare. Since 2013, the Sea of Galilee has receded 11.5 feet, losing more than 100 billion gallons of water.
We are facing terrible climate change. Unbelievable. 5 years of drought and less rain. By the end of 2018, the water level of the Sea of Galilee will be close to what we call the black line, the lowest level ever.
And it would take an enormous amount of water from the Sea of Galilee to stabilize the Dead Sea. More water than Israel desalinates every year. As much water as it uses for its entire population. And desalinating more water presents problems as well.
This is already an issue that is being discussed in Israel. What is the impact of the desal? This, of course, has its price, environmental price too. You increase the volume of reject brine to the Mediterranean. There are studies now underway. How much can you desal before you see the effect?
So where does the $10 billion Red Sea Dead Sea project stand? After years of planning and scientific study, money still needs to be raised. But using water as a way to lessen tensions in this conflict-prone region is an opportunity that may be too good to pass up. But will the Dead Sea be even further damaged by this geopolitical bargain? The scientists are worried about the impact of the project. Some believe that instead of trying to save the Dead Sea, we should study it, to gain a deeper understanding of how nature responds to the damage we've already caused in just the last half-century.
This is a natural laboratory. We're witnessing geological processes that usually happen over periods of thousands of years, even longer. And here, what we see, we are observing these processes on a very short time period, possibly even at an unprecedented rate, which allows us also to study them. I think this is something that is very unique.
In my opinion, nature does not need to be saved if we treat it with respect. I would make the whole Dead Sea Basin a geological park. Because we see things here that we don't see anywhere else. Some people can see it as damage. I see it as an interesting geological phenomena which is spectacular.
This is a particular deep one.
There is a risk. If we do the project, there is a risk. If we don't do the project, there is a risk. I wish that this project sees the light, but we have to address things correctly. We have to address things wisely. We have to address the consequences of climate change. We have to address also the consequences of human intervention.
In Jordan, the water shortage is getting worse.
Jordan cannot wait. We don't have time. Our water resources are drying up. Our demand is increasing. We need water.
And for the Palestinian Authority, there is also a desperate need for water.
No one can deny the importance of water.
As for the Dead Sea, its level continues to decline, with no end in sight.
In Yiddish, they used to say, "Man tracht und Gott lacht." That is to say, the man is working and God laughing.
I don't think that the Dead Sea is really upset that it descends or something, but it's only for us. I don't want to tell my children, there used to be a sea here and it was really nice, we could float on it, and I want them to be in it and to feel it and to see it. It's a treasure.